Hello there, my name is John Tojek, and this is an Xfrog with Maya tutorial covering wind expressions. It's 3 parts. First, expressions and variables. Number 2, add motion to an existing Xfrog tree. And number 3, exporting this motion with an Alembic cache for Unreal Engine or any other package you would like. Here are some examples, but let's begin. Here, we have the average man walking on the beach in Rio de Janeiro. And the first thing I will do is put down a branch. Let's make this branch larger by scaling up the curve and the circle. This is something I've done in every other video. We're just going to use these curves of the extrusion to get ourselves a nice, perfect branch. Let's turn off the GPU and look at it in real time. I'll give it a simple green shader, and what I'm planning to do here is build a super simple abstract tree with 3 branches. I just want cylinders, so I delete the points, I make it the same thickness. I make one the child of the other. This second branch, I make this larger, and I will make this also into a simple cylinder with a green color. The purpose here is to place down branches, and then I'm going to add motion in a simple way so that we can all see and understand what the variables are doing. Along with making them a cylinder, I'll make them the same length, so I modify growth. And then I have a third branch. This one is going to be the leaf. I make them into, I'm going to make them by turning the curve at the bottom, the circle, into an oval. I'll give them like a fin, like a shark fin. And then, if I play with the screw variable, I can put them all to be facing up. So now, they're like fans, blades of a fan, and I can control them. I'll give it a nice small number, and these are the leaves that we are going to play with. So I start by adding an expression. I'm going to do motion. First thing to motion is with keyframes. Any one of these variables can be keyframed, so I'm going to start with screw. As I keyframe screw, I'll give it a slight motion from 0 to 300, and it will twist these fins around the branch. So there I hit play, and I can see them go. Now, in addition to setting keyframes, the other thing you can do is set expressions. So we're going to use expressions and formulas such as sine, cosine, and noise with frame or time as our engine. So if I put sine of f or frame in there, I can see them giving me a sine wave, sine of t for time. So they're going all the way left, all the way right, just like a sine wave. It's going to the top at 1, to the bottom at -1. If I need it to go faster or slower, I divide by a number, divide by 2. If I want it to go faster, I multiply by 2. So this is the period, or how fast that sine wave is going to go. I can do cosine. And also in the end, I multiply times 0.2 to make it move a smaller distance. In addition to sine and cosine, there's noise. Noise is a pseudo-random function. It goes between a maximum and a minimum in a wave, but it's random. Luckily, it's pseudo-random, so it's repeatable. We can do it on many machines for rendering. Then I multiply by x. X is the actual value of that curve. So that thing is keyframed, it's changing, but x is that parameter curve that we always play with. If I do u is a number from 0 to 1 along the length of the branch. So u is a good way to make the leaves have a different behavior at the beginning of the branch than they do at the end of the branch. The last variable we play with is I for iterative, and that will give different behavior between different branches. Each branch has his own I value, starting from 0 to the top branch, which here is 6. So in this case, I have noise and u, and that's how you start to give motion to these things. We're doing motion that is partially from keyframes and partially from the expression that we add. To have a motion, you need t or f, which is frame and time, to make it happen when you hit play. So right now, I've got to file it down and get to something repeatable. I just want like a little bit of leaf happening. Here I'm adding a sine with frame and then noise with t. You know, it's getting a little obnoxious. Let's try to experiment with a just a sine wave. So here we have sine wave f times 0.1, noise f times 0.1. And this is giving me a shaking. I just want like a little windy shake going on. The next thing I'm going to do is play with node distribution. So this changes how they are on the, I want an equal space between them on the branch. So I've got a bunch of them, they have noise going through them, and they're just shaking back and forth. Remember, I can play with the speed of that shaking or the amplitude. One more thing, I'm going to add a little node flap. So it's going to make them turn. I'm going to put a point in the middle, and I'm going to keyframe this point. And remember, to make these expressions evaluate in XFrog, you do have to keyframe one of the points on your parameter curve, which is X. So right now, it's moving only because of X is animated, but instead of that, I will add X plus a noise. Noise, frame times 100. So now I'm getting them to turn. And if I do I in there, then I have a different turning per branch. And then I add U in there between 0 and 1, so it will turn different at the beginning of the branch to the end of the branch. U is such a small number, I usually multiply by 100 to make U have more of an effect. You can either multiply it to what you're doing or add it to what you're doing. So these are the main variables. T and F for time, they make it happen when you hit play. I for difference among branches, U for difference in one branch. Then X is the variable that we create with that parameter curve. So now I'm just going to node angle these guys up, and I'm going to make some sort of a tree. It's going to be a very abstract tree with a very radical leaf motion. And not only will it have the leaf motion, I want the trunk to move with tropism. Oh, before I do that, I'm going to add a curve NURBS. I replaced the original curve, hit the plus sign, and now my curve NURBS is in there. I can control the length. This is a programmable curve. Almost all the XFrog plants use curve NURBS quite a bit because it's more powerful. That means you can do X rotation of that curve NURBS, and this is how we get a normal noise into the shape of the curve. So this noise has no animation. There's no time or frame in there. This is just the noise to give it a movement, okay? Once I want to add time, I got to do two things. First, I got to keyframe one variable in that formula that I want, and then I'm going to add time or frames, T or F, into my equation, and I'm going to give them a flapping. So I'll just do times noise of time. Okay, now I can see I'm getting some motion along with the previous expression, which made them gnarled or curved. It gave them a random noise. So I can make that noise more complicated, make sure that each branch using T, I, and U, make sure that they're all a little bit different. And then, you know, if I want it to really be active, times 22. If that's way too much, times 12. I'm just changing the magnitude of how far it's going to move. And then I might also change how fast it moves because it's really flying. Next, I'm going to add tropism. Tropism, I'm going to add it to the trunk. And that means that the whole tree is going to move in a direction I decide. We're going to move it in plus Z. And is what it is, it's like a wind is blowing it. So the first and last frame, I'll leave it at 20, and my middle frame at 150, I'll just jam that up to 222. So now, as the time travels from 1 to 300, I'm beginning at a place, pushing far in positive Z, and then ending at a place. I'm going to add another tropism to the branches. This one is plus Z again, and once again, I'm going to keyframe. The beginning and the end are just 20, that's my default, and then in the middle, they're flying really far in positive Z. And the last thing is a tropism for the leaves. I want every part of this tree to be reacting to this wind. So I put tropism in the leaf, hit the plus sign. I tell it a positive Z, and then I'm going to add an intensity animation. 20 at the beginning and the end, and then I go to the middle, which is frame 150. You know, actually for beginning and end, I'll do negative 100. So these leaves are going to go way negative Z, and then in the middle, way positive Z. So they're going to have an exaggerated motion, but it's just really pointing towards this tree is flying through a serious hurricane. We are in Rio de Janeiro, actually, so it's totally understandable. You'll see Pão de Açúcar in the background, and there we have the tree in GPU. Luckily, it's a very light tree. There's not too much math going on here. Sometimes when you do a real tree, you get a lot of formulas being evaluated, so it's pretty slow. But this one is nice and abstract, and I did it in real time just so you can see the expressions as I put them in there. So When we're done with the GPU here, let's select it, and here we can see a rendered version. You could either play blast it or just render it out. It's clearly some strong wind happening there by the beach in our abstract tree. Now, this is part 2. We really want to add motion to an existing XFrog tree. If you go to the XFrog website, you can see all the different catalogs they have. And here we're going to go to the Asia catalog, check in English, and we'll scroll to the back, and I'm going to choose the tropical almond tree. So this one has nice big leaves that'll catch the wind. They're great for motion, and it's a fairly complex tree. So I bring this guy in, and we're going to show the exact same workflow on an existing XFrog tree. So I'm going to start with understanding this tree. I look at the different parts. It has 4 main branchlets. So 3 big branches, 4 branchlets. Under those 4 branchlets are 2 leaves each. To simplify this tree, I will go to the main branches and I will turn down the node number to 1. The goal here is to have less XFrog things to calculate. We want a simpler tree while we're adding animation, and then when we're done with the animation adding with the expressions, we will then bring it back to a complex tree. That way we speed up our workflow. Okay, I look at this branchlet and I'm deciding what am I going to do first. First, I'm going to add something to the leaves. I'm going to add motion to the leaves. Could be just a ambient motion, or in this case I'll make it a little more flappy. Now remember, it already has an expression in there, but that expression is really just for placement. We're going to add one with keyframes. We need that to evaluate it, and frame or time. So I set some simple keyframes on these leaves. Just one variable. The variable that we chose was flap, and we're just going to set 2 keyframes, and we're going to change the placement expression to be, x plus a sine wave divided by 90. Unfortunately, 90 is so much you barely notice it. So I divide by 9. That'll make it go faster. And also, in the end, it's multiplied by 0.3. Well, there we go. Divide by 2. So that way it's much faster. And then instead of 0.3, let's do 0.9. That will be the range. That'll make it larger, a larger amplitude. Those are the 2 main things you're dealing with, speed and amplitude. I can do a sine, a cosine, or a noise. Otherwise, I'm just going to grab that one, copy it, and paste it into my next leaf. The one thing you have to do is set 2 keyframes only to make sure that XFrog evaluates the motion. Now, I can add a little variety here. Now, I start changing 0.9 to 0.5. That makes each set of leaves have a little different motion. And then I've copied that expression, and I'm going to move over to my next branch and my next set of 2 leaves. So these 2 leaves, they already have curved NURBS inside of them because almost everything is built with curved NURBS. So if it wasn't, I would put a curved NURBS in there. I replace the expression that was only used for placement, and now I set my keyframes and I do it to the first leaf and then the second leaf. It's just a cut and paste for expressions, and add 2 keyframes. These keyframe numbers are not really important. I'm keeping them very small, but you can change them and add variety between each set of leaves. And that will help you keep a very random motion to a large tree that has many things going on. Here I'm going to replace the sine wave with noise, and I'll put a 0.9 in there instead of 0.5. There's as many variables as you want to make this super flexible. And here I'm just going to speed up the process because it happens 8 different times on these 8 different sets of leaves. The reason this guy has 8 leaves is to make a full variety for a tree, and the XFrog trees can be as complex or as simple as you'd like. Once I've put all of those leaf expressions in there, I'm going to start now adding tropism. I'm going to put tropism on the trunk first. And that means I grab trunk, hit the plus sign, and I say positive X. I'm going to add an intensity curve, positive Z. And then I want my intensity, I'm going to add a little more keyframes. This time I'll put one at 1 and 300. Those both be at 0. And then one at 75, 150, and 225. So it's going to go 100, negative 100, 100, and then back to 0 for a looping animation. You can see I can run it in real time because we don't have many leaves going. And now I'm going to add that same tropism to the branches. There's two main branches I'm going to put this onto, and it's going to be 0. The only thing I'm going to do different here is I'm going to delay the branches. So instead of 75, I'll do 85, 160, 235. And that way, the branches are going to move a little bit after the trunk. That's an offset, an animation offset, a keyframing trick everybody does. I'll be doing the same process to the leaves as well, because they will also get the tropism, and I want them to be even more delayed. So it's pretty much like the trunk goes first, the branches go second, and then the leaves go third. One thing I can do here is put the word wind into each of my tropisms just to keep track of them, because these leaves, they already have a tropism that pulls them down to the ground. We're giving them a second one that animates in the wind. Notice, each and every time I do this, I'm going to add a keyframe to the tropism, or to the branch, and make sure that the expression can go. Now I can go back to node number and replace in my old numbers. Instead of a 1, I put a 24 or a 15, whatever they were before, so I have my original tree. If I would like, I can make those numbers much higher and make a more complicated tree. Here's a play blast. So I play blasted along the way just to see how it goes as I'm experimenting with this. And these take a little time. Even better is a render. A render is you finally see the full thing, and I can see this is a very stormy tree. It's going through left Z, positive Z, and negative, and all of the leaves and branches are offset and animated, so they're flying after it. So that's an example of a very stormy tree. Now here we look at it with the GPU. Xfrog works with all the Maya stuff, and in real time I can see the different frames. It's not going to move in an animated way. But now, this is part 3. We're going to export selection to an Alembic cache. This is a little tricky because you have to be careful on how you select the surfaces. Here, we look at the trunk. It's a surface, and we can see it in the hierarchy, but you can't click it. If you click right on the tree, you're not selecting the trunk. And that's because it has a special attribute set. Xfrog sets the attribute to be non-pickable. So display type reference, we want to change that to display type normal. Then you can select it with your key, with your mouse. So I'm going to do this to the whole tree, and I'm going to use the attribute spreadsheet, because that way I can do many surfaces all at once. So I pick the tree and select mesh. Xfrog selects all those pieces for me. I go to the All tab, and I want to find that same attribute in a spreadsheet. I put the number 0 in there, so it changes reference to be normal. Normal is 0, reference is 1. Now that I've modified that attribute on multiple surfaces, I'm going to hide those things because I know they're done. And I'm going to do it to the next branch that I missed. Select Mesh, go to my Attribute Editor, and to the All tab. I'm going to go find the attribute Override Display Type. Set it to 0, which is normal, and then I can hide them because I know they've been set. The trunk I already did. I did that one by hand. But you know, when you have a lot of surfaces, it's easier to use the attribute spreadsheet. So I bring the things back forward, and I'm going to make sure that I can select them now. Now with the mouse, I can select all the pieces. I'm going to make everything else invisible. I'm going to use my pick mask. So I only am selecting the surfaces I want, polygon surfaces. Now it is safe to export as an Alembic cache. Let's look at the options. I'm just going to export the selected items. And that's 1 to 300, your frame range, that's the most important. Here we want UV right and right face sets. This is a suggestion from Unreal Engine 4 documentation. Then I name my tree. It's number 29, the new one, and I hit export. Notice it's going to calculate as it goes out. This is a little bit slow because there's a lot of branches and a lot of leaves, but it is writing it out in a cache that will be real time as soon as we put it into any other package. Now that it's done, I bring it back into Maya. You should always test your things after you export it. You want to make sure it's clean. You want to make sure it worked. So you import in an Alembic cache. You can see all the pieces in the outliner. There they are, the 16 pieces. And I'm going to group them and scale them up by 300 to get them back to a normal size. One other issue that I see here is the normals are reversed. So those black trunk, you just go to reverse normals. And there it is. It's in real time. I can play it. The cache is there. I could stretch it, time warp it, reverse it, whatever you want. The cache is the most flexible way. Now that Alembic export exported the motion for us, but not really the materials. So I'm going to do an FBX export which does the materials for us. So I do all the standard things. There's animation off. I just need embed media, and that will for sure take the materials out of my Maya file and export them. So I'm bringing two parts, motion and materials, Alembic Cache and FBX. Here I have a typical Unreal Engine file. This is a bunch of Xfrog trees in there, and I import in the Alembic. The one thing I do, I have my frame range, geometry cache, and flatten tracks. That makes and create materials. That way I get 3 slots to put my materials, so it automatically breaks up all the parts. I drop this guy into the scene, scale him up, orient the tree the way it's needed to be, and there it is. The cache moves. One thing I can do with this cache is I just select it and I can change the speed of the cache. Here it is, 21. That's the Jacob's Ladder cache. Now I bring in the FBX the same way, and this guy is going to come in with materials. So I have no animation, no mesh, and I say create new materials, import textures. It will bring these textures in, give me the 3 materials in Unreal Engine. They're fairly simple at this point. They really just have the diffuse and the opacity, the shape of the leaf, and then I drag them onto the 3 main surfaces of my tree. In this way, once they all compile, I can hit play, and there I have my animated tree. Next, I'm going to duplicate this guy around the scene. And keep in mind, these are simple materials. They're basic, but they give you the slots and the place to start. And because I made 4 duplicates of the tree, I can change the speed of each one. So each guy has his own cache, and it treats the cache differently. So I start from a different offset point, and that way I can have a slightly different animation on every single tree. And that's a very cool effect. I could make this looping better in Maya, or I could loop this in the sequencer just as well. But that way I can have a huge variety of animation throughout. Well, that's how you go Xfrog, Wind, Motion, all the way to Unreal Engine. I hope you enjoyed. Talk again soon.